Trigonometric identities. De Moivre's theorem may be used to establish certain trigonometric identities, such as to write cos n theta and sin n theta as polynomials in cos theta or sin theta. To expand cos n theta or sin n theta as polynomials in cos theta or sin theta, these are the 4 steps we follow. Step 1. Write De Moivre's theorem in this exact form. Cos n theta plus I sin n theta equals cos theta plus I sin theta to the power of n, which equals c plus is to the power of n, or kiss to the power of n, where c is equal to cos theta and s is equal to sin theta. Step 2. Using algebra, expand c plus is to the power of n, gathering real terms and imaginary terms. So real with real, imaginary with imaginary. Step 3. If cos n theta plus I sin n theta equals a plus ib, then put real equal to real, so cos n theta equal to a, if we want to expand cos n theta, or imaginary equal to imaginary, so sin n theta equal to b, if we want to expand sin n theta. So you ignore the i's for the imaginary. And step 4, finish by using cos squared theta plus sin squared theta equals 1, or in short, c squared plus s squared equals 1. Use De Moivre's theorem to show that cos 3 theta is equal to 4 cos cubed theta minus 3 cos theta. So step 1, write De Moivre's theorem in this exact form. Cos n theta plus I sin n theta equal to cos theta plus I sin theta to the power of n, which is equal to c plus is to the power of n, where c is equal to cos theta and s is equal to sin theta. So by De Moivre's theorem, when n equal to 3, so we're basically going to swap each of these n's highlighted in blue for 3, we get cos 3 theta plus I sin 3 theta equals cos theta plus I sin theta to the power of 3, which equals c plus is to the power of 3, where c is equal to cos theta and s is equal to sin theta. Step 2. Using algebra, expand c plus is to the power of n, gathering real terms and imaginary terms. Then by algebra, although we can also use binomial theorem, c plus is to the power of 3 is going to be c plus is to the power of 1 multiplied by c plus is to the power of 2, because 2 plus 1 makes 3. We can bring down c plus is as it is with brackets, and we're going to multiply out c plus is squared, and that will give us c squared plus 2csi minus s squared. Next, we're going to multiply out these brackets. So c times c squared is c cubed, c times 2csi is 2c squared si, and c times minus s squared is minus cs squared. Then is times c squared is c squared si, and is times 2csi is going to be minus 2cs squared. So the minus comes from I times I is I squared, and I squared gives us minus 1. So that's where the minus comes from, and the I disappears. And then is times minus s squared gives us minus s cubed I. So next we're going to gather the real terms. So c cubed minus cs squared and minus 2cs squared gives us c cubed minus 3cs squared. So these are any terms without i's. Next we gather the imaginary terms. So we have 2c squared si plus c squared si minus s cubed I, which gives us I times 3c squared s minus s cubed. So we factorize out the I. Hence, cos 3 theta plus I sin 3 theta is equal to c cubed minus 3cs squared plus I times 3c squared s minus s cubed. Step 3. If cos n theta plus I sine n theta is equal to a plus ib, then put real equal to real. So cos n theta equal to a if we want to expand on cos n theta, or imaginary equal to imaginary, which is sine n theta equal to b if we want to expand on sine n theta. So we want to expand on cos 3 theta, so we're going to put the real equal to the real. So we're going to put cos n theta equal to a. So we're going to put cos 3 theta equal to c cubed minus 3cs squared. So as we want to expand on cos 3 theta, we put real equal to real. So we have cos 3 theta equals c cubed minus 3cs squared. Step 4. Finish by using cos squared theta plus sine squared theta is equal to 1, which is, in short, c squared plus s squared equals 1. Or we can rearrange this to get the s squared on its own. We have s squared equals 1 minus c squared. So we're going to do that. We're going to get the s squared on its own. We could have got the c squared on its own, but we want the s squared on its own because we have an s squared here. So since we've stated here that s squared is equal to 1 minus c squared, we're going to swap this s squared for 1 minus c squared. Just make sure you've got brackets around it. So we still have the c cubed and the minus 3c. So we're going to bring down the c cubed, and then we're going to multiply in the minus 3c. So minus 3c times 1 is minus 3c, and minus 3c by minus c squared is plus 3c cubed. And then we can simplify. 1c cubed plus 3c cubed is 4c cubed. We still have the minus 3c. And we've simplified now as much as we can, so we break it back open. So 4c cubed is really 4 cos cubed theta, and minus 3c is really minus 3 cos theta. So this is our final answer, and that is what we were asked to show up here. So to summarize, we started by writing cos 3 theta in the form of cos 3 theta plus I sine 3 theta, which simplified to c plus is to the power of 3 using de Moivre's theorem. We had n is equal to 3. Then we took the c plus is to the power of 3, and using algebra we expanded the brackets. Alternatively, we could have used binomial theorem, but since it was only the power of 3, it was easy enough to just expand the brackets. And then we put the real parts together and the imaginary parts together. Then we had a look and we said, well, we're interested in cos 3 theta, and we know that cos relates to the real part, so we're going to put the real parts equal to the real parts. So we're going to have cos 3 theta equals c cubed minus 3cs squared, and then we replaced the s squared with 1 minus c squared, because we know that sine squared theta plus cos squared theta equals 1. So rearranging that, we get sine squared theta equal to 1 minus cos squared theta, which simplifies to s squared equals 1 minus c squared. And then we multiplied out the brackets, we simplified, and then we rewrote 4c cubed as 4 cos cubed theta, and minus 3c as minus 3 cos theta. And this is what we were asked to show.